All right, so good day and welcome to everyone attending today's webinar. I'm your host, Zaid Doleh, Enterprise Cloud Architect at Prolifics, a digital transformation consultancy. I am joined today by my colleagues, Dr. Michael Gonzalez, Chief Data Scientist, and Shameeza Ali, Account Executive for Cloud Solutions. We are very excited about sharing with you a solution we are calling Data Science in a Box, a turnkey data analytics and machine learning solution using best-of-breed technology partners, including AWS, Snowflake, Talend, and DataRobot. In this webinar, we'll be providing you an overview of our Data Science in a Box solution and demonstrate how it's helping enterprises unlock the actionable insights from their business data. There will be a question and answer session at the end of the demo, so please use the Zoom meeting chat box to ask your questions. And remember, one lucky attendee will be randomly selected to win a one-time $500 AWS promotional credit at the end of the webinar. So without further ado, I'll hand it to Dr. Michael Gonzalez to walk through the Data Science in a Box solution.
Thank you, Zaid. We're going to start today's presentation by just looking at a quick agenda. We're going to divide this up into three different sections. We'll start with why and what is data science in a box. We'll take a look at the products and architectures used in the demo, and then we'll actually show you a data science in the box demonstration. So the first slide I want to take a look at is this findings, this report that was published this year. And what it clearly demonstrates, and it certainly is not challenged in the industry, it demonstrates the growing demand, the increasing demand for AI and machine learning, as well as the very low supply of data scientists capable of doing AI and machine learning. And as a matter of fact, this gap that you see here, Gartner believes that it's going to be filled by a term that they've coined called Augmented AI. In other words, technology that is going to be a force multiplier for the existing data scientists to get more stuff done, as well as an enabler for citizen data scientists to actually contribute to this lost opportunity. Gartner believes that by 2021, the augmented AI space will be responsible for generating close to $3 trillion worth of business value. For Prolifics, our augmented AI comes in the form of what we describe as a machine learning assembly line. And what we look at is from soup to nuts. We look at, from one end, just the data sourcing, just collecting all of the different disparate data that is necessary for data science type of projects, all the way across to actually publishing and consuming the results of an AI project. And more specifically, we have, in our data science solution, we have three different technologies that we pull together in a single pipeline, in a single assembly line. We have Stitch, which we're using for data ingestion. We have Snowflake for our data munging, data wrangling and storage. And then we're using DataRobot for the automated ML capability. All of these, by the way, are part of the Accelerate Partner Program for AWS. When you combine these three together and you manage them as a single solution, we really open up the variety, the landscape of use cases that you can address. And we're not tied to a particular industry. So any of these use cases can be applied to telco or automotive, manufacturing. It isn't really tied to any one particular industry. So our solution is really taking all three of these and combining them as a managed service, a single, fully turnkey type of solution for our clients. So if we look at each one of the technologies in our stack, we start with Switch. Switch is a Talend product, and it's really a simple data consolidation platform. It allows us to pull from some of the biggest cloud instances out there. There's drivers that are already set up for 90 plus, and it continues to grow, of some of the biggest cloud instances out there. We are working with Snowflake as our data storage solution. And not only does Snowflake allow us to consolidate disparate data in an organization into one single repository that we can have access to, but more importantly, Snowflake provides on-demand scalability. So in other words, if we have a ton of SQL requests pounding our data on noon on Fridays, or at the end of the month book closing, what Snowflake will do will automatically throw more resources so that the throughput continues to be high. Now, we've seen performance increases of in excess of 200% when you compare Snowflake performances to on-prem type of solutions. And of course, they're offering this as the great business model of paying by the drink. So you only pay for what you're using. For our automated machine learning technology, we're really, our technology of choice is DataRobot, which is best of breed. It literally is a robust, comprehensive, automated ML solution that, again, will be a force multiplier for your data scientists and make your citizen scientists equally competent. And one of the big things that I like to remind people of with automated ML is the fact that you can throw hundreds of algorithms at a solution. So when you look at a typical data science project, you might only experiment with 3, maybe 5 different algorithms. With DataRobot, you certainly can have hundreds of algorithms test that same data set in order to determine which one is the best for your solution. So let's just take a closer look at our demo architecture. So using those 3 technologies, we're going to provide a demonstration of a use case that we work with in our consulting business, which is churn. Now, when we deal with customers that have a churn or need a churn type of solution, we're looking at a broad range of disparate data. We're looking at anything from, help desk trouble call tickets all the way to in a telco solution, we're looking at friends and family, right? So is this individual who's a client of ours, is this individual an influencer in their social network? Is this individual a bridge to another social network? Which really, makes it a lot more important for us to understand if this individual might churn on us, they may take others with them. And we also look at a broad variety of other type of data, demographic information, along with information that might help us determine the lifetime value of the client. So in our case, what we're setting up is 3 different CSV files. We put those out on Amazon S3. Now these 3 files, they're just sample data, right? We can't actually show any of our client data. But in this case, we have some customer demographic data. We have some data about the type of services that they're using. Are they streaming TV? Do they download movies? That kind of stuff. And then we have payment information, and essentially a history, how long they've been with us, how do they normally pay, what is the size of every invoice that they pay, that kind of information. We put all 3 of these out on Amazon S3. We're going to use Stitch to source out of Amazon S3 and populate these CSV files as relational tables in Snowflake. Then we're going to use Snowflake to do our data wrangling and create one flattened record that is going to be consumed by DataRobot for the actual churn scoring. So why is this solution better than your traditional type of data science efforts? Well, it's a really simple issue about scalability. If I do that same type of churn, which we have, given a more traditional type of solution, I'm going to have data engineers going out to look at the different sources, make decisions about how they're going to source that data, and then they're going to make determinations about where they're going to place that data, how is it going to live, how long is it going to live, all of that, those kind of issues have to be decided. They're important issues, without a doubt, but that takes time. And then I'm going to have my data scientist, that individual is going to go and maybe run 3 algorithms, maybe upwards of 5 algorithms, because they don't have that much time to test which one might do best against that particular data set. And then we have the whole deployment issue. So you can imagine this is literally months, even for the most efficient traditional data science teams, this is an effort of months. With data science in a box, we really reduce that to weeks. We really can crunch it all down, and not only can we reduce the amount of time it takes to get a solution out, but we can do a better job of and bring better value while reducing that time. In other words, I gave you the example of DataRobot. DataRobot, we're going to be able to do our due diligence against 100 different algorithms as opposed to just testing 3 or 5. With Snowflake, we can do our data wrangling in one environment. With Stitch, we can actually consolidate and make that environment possible in Snowflake. So we really reduce the amount of time it takes to get something done while dramatically increasing the type of work that we can do and the amount of work we can get done, as well as the value of the final outcome. So let's take a look at a demo. Now, in this case, we have a demo that's videotaped just to avoid any kind of technology issues. And in this demo, we divided it up into 8 steps. There's nothing magical about the 8 steps. It just helps us to talk about the video. Here we're in Stitch, and all we're showing you is all the different pre-configured drivers that are available in Stitch. In this particular demo, we're going to use Amazon S3. And for Stitch, all it really needs to know is how do I log in? What are my credentials to Amazon S3? And where is the data that you want me to get access to? So in this case, all we're doing is putting in the credentials into Stitch so that it can access my S3 account. We tell it what bucket to look at. We tell it what data to look after. So in this case, we want all CSV files that are going to be in the customer underbar data folder. And then we give it a name, and basically that's it. So now we click continue. Now we're in step 2. Now we're going to connect up to our target, which is Snowflake. And again, all we're really doing with Stitch is just letting it know how to talk to Snowflake. So what are my credentials to log into Snowflake? And that's all we're doing here, is putting in our credentials. And then we would put in a little bit more information about what database we want to access, what warehouse we want to access, and then give it a role, basically. Now we have both our target S3 and our source S3 and our target Snowflake. And now what Stitch is doing is just checking the entire configuration. So it wants to make sure that it can get access to the S3 environment, find the data files that we're looking for. It wants to be able to connect up to Snowflake and make sure that everything is where it's supposed to be. If we look at our dashboard in Stitch, right now we don't have a lot of information about it, but here's where we would have information about the pools that we've made over the course of time and a lot of kind of ops information. At this point, here's the tables we want to create, and all we're going to do is click on Run Extraction. Now what Stitch is doing is going out to S3, pulling in all 3 CSV files, and creating 3 separate relational database tables in Snowflake. And now we're in step 4, which is the actual viewing the data in Snowflake. And as you can see, those CSV files now have become relational tables, storing that same data, which means that if they're in relational database, there's any number of things that we can do with those tables. We can add constraints like IDs or parent-child relationships, any of that kind of stuff that can be done. Anything that we can get done in a relational database, we can do here. Which, to our point, I'm going to freeze this just a little bit here. This is our SQL code that's going to do our data wrangling. We're going to take all three of those tables, all the data that's at different granularities of those three tables. We're going to do one join together and create one table that's going to be called churn. And that table is going to be a flattened record that is going to be the source of data that's going to be consumed by DataRobot. And that's our step 5, which is doing the data wrangling. Again, we can do anything in Snowflake that you can do in any relational database, which gives us a lot of power. All right, so at this point, now that we're just showing you the actual churn data, the composite of all three of those unique tables. All we have to do now is let DataRobot know that this data is ready to be consumed, which takes us now to step 6. So now we're in DataRobot. And here, what we're doing is just telling DataRobot how to connect up to Snowflake. And so we give it the connection name, we give it the credentials that it needs to actually get access to our Snowflake environment. And now what we're going to do is take that connection and we're going to tell it what source of data we're going to use. So it's going to go out there and pick up the schema, and we're going to select one, and then it's going to come back with the tables that are available, and we want churn, and we're just going to give it a DataRobot name. So this is churn data. So now we've connected DataRobot to Snowflake, and we're accessing the single churn table that was created out of all three of those disparate data sets. So all that's left at this point is to just actually use that data in a project. So here we're going to create a new project, and identify our data source, and select it, and now it's bringing in the data from Snowflake in that churn table directly into DataRobot. Now I'm going to freeze this for a second here. All of the data that was in that churn table in Snowflake has now been ingested into DataRobot for processing, for scoring. Now there's a lot of things you can see here at this juncture. It's just started reading it in, and it's already starting to profile the data so that it has a basic understanding of what kind of data it is, whether it's categorical or numeric, and if it's numeric, what's the min, max, all of the typical meat and potato profiling that you would expect to be done. But we're not going to, if you clicked on any of these, you'd see a lot more information. We're not going to worry about that just yet. What we're going to do is create a threshold. So that means all I'm going to do is tell it what feature, what column I want to try to predict. In our case, I want to try to predict this churn value. So I'm just saying this is my target. I haven't done anything with any of this data. And now I'm just going to simply click on Start. Now what DataRobot is going to do is throw 100 different algorithms at this data, at the exact same data set. And it creates what's called a leaderboard. And now we're into step 8. So what DataRobot was able to do was literally test 50, 60, 70 different models. You can test upwards of, I think it's like 300 now, of different types of predictive models and plans against the exact same data set in order to determine which is the best performer. And that's the top of the leaderboard. And you can click on any one of these models after they've done their performance, and you can see a lot of detail. In this case, this is the plan that this model executed against that data set. There's going to be other models with other plans. This gives you a more detailed plan for another model against exactly the same data set. And there's a lot of information that's provided along with the model, prediction time, along with very specific information. There's lots of information buried under each one of these tabs. I can evaluate the model. I can understand where it's getting, how it's come up with its predictions, describe the model, so on and so forth. In this case, we're going to look at understanding the model itself. Here, the feature that is the most significant predictor for churn is our tenure attribute. So here's a lot of information that a data scientist loves to get their hands on. This is information that most citizen data scientists probably aren't capable of doing. So it's giving them access. It's enabling the citizen data scientist. And we end here with this batch prediction. So just right out of the gates, without publishing anything out or doing anything more, all I've done is run against the leaderboard, and now I can drag my raw data right up here, and I can actually even do batch predictions against that data. So that's the demonstration. And now I'm going to turn it back over to Zed.
Great, thank you, Mike. And so at this time, we'll take some questions from the audience here.
Okay, perfect. So let me go ahead and start with the first question we have. Does the data science in a box solution address use cases across many industries, or is this an industry-specific solution? Mike, why don't you go ahead and take that question?
Great question. I had mentioned earlier that the data science in a box really just opens up a landscape of use cases that isn't really tied to any industry. So I've given you an example of churn for telco. We're doing a build to shelf, in other words, forecasting demand for a product that we haven't sold yet. We're doing that for an automotive industry. So there isn't really any limitation of industry nor use cases.
Okay, great. Thank you so much, Mike. Next question I'll pass over to Zaid. How does the data science in a box solution compare with AWS native service offerings, such as SageMaker and Redshift?
Good question, Shameeza. So what we're seeing, especially with the announcements made last week at reInvent, there's some enhanced features that SageMaker provides, such as autopilot or for advanced machine learning. So DataRobot is more of a complementary solution versus a replacement solution for SageMaker. One of the benefits that we see from SageMaker is that it's really an end-to-end solution for machine learning essentially from a process perspective. So we're looking to essentially bring a more native solution to data science in a box versus using partners like DataRobot and Snowflake. So really there's two variants. We have the best of breed is what we're calling, is what we demonstrated. And we're looking at delivering a more native solution, which is SageMaker Redshift.
Okay, great. Looks like we've got one more question before we announce the prize winner. Who can I contact to discuss data analytics and machine learning use cases and a POCs? Zaid, how about you take that one?
Absolutely. You can reach out to me, Zaid Doleh, or Shameeza Ali. We'd be delighted to help you with any follow-ups. Any more questions, Shameeza?
Nope, that is it. How about you go ahead and announce the winner of the prize?
Okay, so drum roll, please. Who's our lucky winner here? And it looks like our lucky winner is Sean Mallory. So Sean, we'll be reaching out to you over email in the next 24 hours with the information for the promotional code.
All right, Zay, it looks like we have one more question that came in. For a person starting to work with data science, should that person go for open source or something like DataRobot?
I mean, the open source options are good. DataRobot, makes it very easy because they have a library of algorithms available, for building data models. And I mean, I would suggest looking at DataRobot first. And if the platform of choice is AWS, looking at some of the tools that they have, like SageMaker, especially with some of the announcements and capabilities that they've announced last week at reInvent. So Mike, I don't know if you want to chime in, if you want to add any additional color there.
Sure. if you're just starting in data science, it's going to be tough just to start hammering out code in Python as an example using Sidekick. It's not going to be a trivial thing. So I guess it just depends on your skill set to a large degree. But if you're just starting data science, it's likely you're going to get better advantage and more momentum using an automated ML technology like DataRobot.
Great. Thanks, Mike. All right. Any other questions, Shameeza, before we wrap it up?
Nope, that is it.
All right. Perfect. So I want to thank everyone for attending today's webinar. We'll be sending out a recording to those who attended, and we look forward to seeing you next time. Thank you.